Good morning to all of you. I welcome you to this session on RDBMS. In today's session, we are going to discuss about record-based physical models, and we'll be discussing about functions in SQL, right? Two topics, record-based physical data models and functions in SQL, right? So let's begin. Like, what is a model? The first question which would come to mind is, what is a model? Okay, so model is simply a way to represent your data. You see, a lot of data is available with us, and first we need to represent it properly so that we can store it, we can analyze it, right? So three models, record-based physical models, are available with us, namely the relational model, the hierarchical model, and the network model. Okay, so to understand these models, I'll take up a specific example with you. This example is a universal example, like which is taken everywhere whenever we are studying data models, and it's a very good example, right? So let me just open up that example for you. I'm opening up this example for you guys, right? Just increase the size here. Yeah, that much would be good. Let's come to that part now. Record-based data models. Yeah. Okay. So you see, a model is a way to represent data, and three models are available with us. Okay. These are the main models through which you can represent your data in a database management system. You see, the relational data model, when we discuss it, it has an advantage that it is simple to implement. Okay. And it uses the table format, like the format which you are already aware of. So that is why the table is also known as a relation. So the tables that you've been working with, the M table, department table, these are known as relations also. So we can call it a table or a relation. Okay. And we construct a relation by setting the association among the attributes of an entity, right? So let's discuss these terms. What is an entity first of all? Okay. So an entity is something which is of interest to an organization. Okay. Or an entity may be defined as something for which the organization is going to maintain data, right? For example, if we consider the case of our college, Amritsar group of colleges, then an entity, you as a student, is the most important entity, okay? Because you are of interest to this organization. So student is an entity. Similarly, in an office, an employee is an entity, and so on, okay? And you see, the idea behind relational model is to use tables to store data, right? Then if we talk of the hierarchical model, it is in the shape of a tree structure, right? So you see, in a tree, there is a root and branches. Normally, when we talk of a tree, it has root at the bottom and branches upwards, right? But in computer science, we always talk of an inverted tree structure in which root is at the top and branches going downwards, right? So hierarchical model, we have the arrangement like one root and many branches. Okay. And we also call it a parent-child relationship. In a hierarchical model, the data is organized in the shape of a parent-child relationship. Okay. We'll see how we represent this parent-child relationship, right? Then in a network model, we simply link all the records with the help of a chain or a pointers, right? Okay. So the relationship is linked by chains or pointers. Okay. So this is also another way of representing your data, the network model. Now, to understand all these three models, that is the relational model, the hierarchical model, and the network model, okay, what we can do is we can consider an example about certain suppliers who are supplying some parts and the quantity in which the parts are being supplied, right? So what information do we have about the suppliers? We have the name of the supplier, the number of the supplier, some status code of the supplier, and city in which the supplier lives, right? These four information are available about the supplier. Then we have information about the parts. What information is there? Part number is there, part name is there, color of the part is there, weight of the part is there, city where the part is located. Okay. And then we have information about the quantity or the shipments, right? So shipments mean, like in foreign countries, most of the transportation is through ships. So that's why the name shipments, right? So in this we have information about like which part number supplied by which supplier number is supplied in what quantity. Okay, so have a look at on the screen. This is the information which we have with us, and our idea would be to represent this information using each of these three models: the relational model, the hierarchical model, and the network model. And then we'll compare that which model is better suited for data representation, right? Okay, have a look at it again. You can take a screenshot so that while we are discussing, you can just refer to that. Okay, information about suppliers, then the parts that they supply, and then the information that which part number by which supplier number is supplied in what quantity. Okay, so if I talk of relational model, you can represent this information by creating three tables: one about suppliers, one about parts, and one about shipments, right? So see, I have done it here. Okay, information is represented in the relational model in the shape of tables or relations. Okay, there are columns in a table which represent the attributes of an entity. Okay, so you know that thing already, that a table contains certain columns or fields of information, and the rows are known as tuples. One new term for you: the rows of a table, they are known as tuples also, right? So what we can do is we can create three tables: one table as S table, one as P table, and one as SP table. So I'm sure that you understood that this is the information about suppliers. So we have taken the supplier number, the supplier name, the status, and the city. So four suppliers are there: S1, S2, S3, and S4, and I have stored the information about them, right? Okay. Similarly, in the parts table, the P table, I can store the information like this. Okay, so you can see that this P table has got five attributes or five columns and three rows, right? This is the first row, then the second row. Okay, these rows are also known as tuples, right? Okay, and then the third table, SP table, in which I've got the supplier number, the part number, and the quantity in which that part is supplied. So fact here: supplier S1 supplies part P1 in quantity 100, and so on. Okay, now if we need to see whether this model gives us certain problems or not, we need to consider something known as an anomaly. Anomaly would be a problem. Okay, so we consider the anomalies of insert, delete, and update. Okay, by this I mean that if I insert something into the tables, or if I remove something from the tables, or I update something from the tables, and if it does not give me any problem, then I would say that there are no anomalies of insert, delete, and update in this model. Okay, so the first problem, let's see, that I need to insert this information, that I have information that a new supplier, okay, has come from area W. Like a new supplier has come from some area with the name as W, right? So to insert this information, we can simply insert a row in the S table. So insertion, you see, is no problem here in the relational model. Let's now look for the second problem, that is of deletion, right? And suppose we have this information now that supplier S3 is no longer supplying part P2, right? So what we can do with this? So what we can do here is simply, you see, that we can remove the tuple or the row concerning S3 and P2 from the SP table. That is this row, S3, P2, just move this row. So deletion also, we see that it does not give any problem in the relational model, right? Next is we need to update that we have got an update information that the supplier S1 moves from London to Paris. Okay, supplier S1 moves from London to Paris. You can see that supplier S1 is currently residing in London. He shifts his city to parents. So simply we can make an update statement here. We can make the update here. And remember one thing, that this update needs to be made only at one place. The update statement causes problems if multiple updates are required at multiple places, and if we miss some, then the data becomes inconsistent, right? So we see that all the three problems of insert, delete, and update are okay here in relational model, and we say that it can be it is a good way to represent our data, right? So we observe that the relational model is free from the anomalies of insert, delete, and update. Anomalies would mean problems, right? Okay. So relational model is free from the anomalies of insert, delete, and update, and is very good for representation of data. Okay. Let's now focus on the hierarchical model, right? So I told you in the hierarchical model, the information is in parent-child form, right? Okay. So how we can represent this information, which we represented using tables in case of the relational model. So what we do here is, we can out of the information that we have, we can consider certain information as superior and certain information as subordinate. Okay. So the superior information comes at the root, and the subordinate information comes at the as branches. Okay. So you can see here, we have considered here parts as the superior information. So one record for part as the root, and then branches. So whatever the supplier is supplying part P1 comes under the P1 root. Okay. Similarly, P2, similarly P3, and so on. Okay, right? I hope it's clear. I repeat, we consider certain information as superior, okay, and certain information as the subordinate information, which would come under the superior. So parts in this example I have considered as superior, and supplier information as subordinate, right? So I take part as the root here, say P1, okay, and then you can look here that P1 is supplied by S1 by S2, right? So S1, S2, these two branches come under P1. Similarly, under root P2 we have S1, S2, S3. So we make tree-like structure, the parent-child relationship, where P1 is the parent and S1, S2 are the children, right, or the branches. Similarly P2, similarly P3. Okay. Now again we will consider this information. Suppose a new supplier comes from area W. Okay. So obviously we cannot insert this information, because we don't know as yet like what part is supplied by the supplier. Okay. The information is only this one, that a new supplier has come into the market from area W. So till the time we know what part he supplies, we cannot insert information about that person, right? Okay. So since we don't know the part supplied by the supplier, so information cannot be inserted, right? This is because, yeah, I can just correct it here. This is because part is superior and supplier is a subordinate, or more precisely, part is parent and suppliers are children, right? So without parent, children cannot be there. So we must have some part information before we can insert the supplier information in this hierarchical model, right? So next problem, again the same problem of deletion. Suppose supplier S3 stops supplying part P2. Okay, supplier S3 stop supplying part P2. Now look at the diagrams very carefully. We have the supplier information S1 and S2 under P1, S1, S2, S3 under P2, and S1 under P3. So if the supplier S3 stops supplying part P2, right? So we must remove this child from this tree P2, from this parent P2. So what happens here is that deletion here would result in loss of information, right? Got it? Like we may lose information about supplier S3. Maybe this is the only occurrence of supplier S3 which is occurring under P2. We don't have any other occurrence of supplier S3, right? So deletion here would result in loss of information, in the sense that if we require, to contact S3 again for some supplies, we don't have his record with us, right? I think it's clear, deletion. And then we have the updation. suppose supplier S1 moves from London to Paris. The same updation that we did in the relational model. Now, if we need to do it here in the hierarchical model, then you see that supplier S1 occurs under each of the parts P1, P2, and P3. Here we are talking a sample, representation of data, small data. Otherwise, when you consider databases of organizations, of companies, it would be containing thousands of records. So here S1 is occurring under three parts. So we need to update S1 here also. We need to update S1 here also. We need to update S1 here also. So multiple updates needs to be performed. And if we miss on some updates, then at certain places, supplier S1 would be living in London, and at certain places, he would be living in Paris. So updation here can result in inconsistent data, right? Updation here can result in inconsistent data. So that is why we have these three anomalies of insert, delete, and update in our hierarchical model, and is not very suitable for data representation, right? Let's now next move to the network model. So as we discussed in network model, information is represented by means of pointers or chains, right? So we have different records here, and we will connect them with the help of pointers or chains, like we do in memory, right? In the computer memory, the information is arranged or set up with the help of the memory pointers. The same concept we'll do here using this network data model. So we have a supplier record, we have a part record, and we have a quantity record. I'll represent it like this. You can see the supplier record, S1, S2, S3, then this is the quantity part, then this is the parts part. So you just arrange it, okay? I've used some pointers here, but you can see that with a few records, there is a lot of confusion and a lot of complexity out here in representing. There will be a lot of pointers, and a lot of expense would be required because the memory management would be difficult and complex and expensive. Okay, so what you need to do here is look carefully. Suppose a new supplier comes from area W. Okay, we can create a new supplier record here. Okay, and whenever we have the information about parts and quantity, we can connect the necessary pointers. So everything is okay in insert here, right? So we can do it like this. Suppose a new supplier is S4 SAM. So right now we can show the pointer is not connected to anywhere. So it is connected to itself. And when it has some part and quantity information like what S4 is supplying, then we can connect the memory pointers. Okay. And suppose the supplier S1 moves from London to Paris. So a change needs to be done just here in one record. So no problem with updation. And deletion, suppose supplier S3 stops supplying part P2. So we can remove the chains connecting S3, P2 and quantity. There's no problem with this. The only problem with this is like it is very expensive to implement the storage of data using record concepts and pointers, number one. And number two, complexity is increased because of large number of records. Okay. So thus we see that out of the three models that we have discussed, the relational model is the best, is the most suitable for your data representation, right? Let's now move to the next part of our lecture. Okay, and we just open up the presentation again. This is we discussed just now. Next, we are going to discuss functions in SQL. So function is something which lets you calculate something and which returns back something, or which does some task for you, right? And you already studied functions in C and C++. So to understand functions, the first thing that we need to know is that there is a table known as the dual table, right? There is a table known as the dual table, which is owned by the user sys, right? And it can be accessed by all the users. It is available to all the users. They can just query this table. Okay. Now what this table contains is it contains one column. The column name is dummy and one row with the value as X. Okay. We'll just see it in our practical session right now. Okay. One column dummy and one row X. Now why do we require it? Like if we need to test our functions, if we need to do any task, without using an existing table, right? We can take the help of this dual table. So it is useful to return a value once only, okay? Which could be a constant, could be a pseudo column, or an expression that is not derived from a table with user data. Okay, so to work with the functions, like sometimes you want to check the functionality of the functions. In that case, you should not be creating a table, then populating it with values. You can simply use this dual table to check all the functions that like we need to discuss in SQL, right? So we'll see what this dual table is. Then we have the functions in SQL. There are two types of functions, column functions and group functions. Group functions we have already discussed in our group by clause. They are the aggregate functions. I hope you remember the sum, count, average, min, max and all. These are the aggregate functions or the group functions which work on a group, right? And then the functions which work on a particular column, they are known as the column functions, which are further categorized as arithmetic functions, character functions, date functions and general functions. Okay, so I'll be discussing these functions one by one, category wise. First I will just show you what the dual table looks like, right? All right, so let me start a SQL session for you, and I can just connect as say user Scott. Okay, as usual I can just make some settings here. Okay, all right, and maybe I can just have a look at my M table. That's a good thing to do because it helps us with so many things. Okay, this is my M table, and similarly I can use this department table, right? So these are the two tables already there, and let's now check the dual table. First of all, let me describe the dual table. So you see the dual table has only one column, dummy. See the size is only one. Okay, so if you just make a select here, say select star from dual, you instead of the column name dummy, you will just see a D, because the column heading cannot be more than whatever is the size of the column. So you will see a DX sort of thing. So you see it on screen. So the column name is dummy, but only D is being displayed. It's because the size of the column is 1. Okay, keep this thing in mind. Okay, now how do we use it? Okay, let me write something here. Select, say I use some function here, sqrt, right? Okay, I write it like this. I want to check a function sqrt, so I've written select sqrt this from dual. Okay, okay, you can see it will take the heading now. Whatever heading you have given here, it will take it, right? Select sqrt this from this. You can also put some message here, like you can just write here, just to illustrate a bit. Okay, some message you can write, it's your wish, but simply even this would be fine. You can check your functions like this. So I hope the dual table is clear to all of you, how we are going to use dual table. Okay, I can use this from the M table also. Okay, let's see if I can use it from a M table. Okay, so it will return as many rows as there are in the M table. That is the problem. That is why we use the dual table. Okay, because when I write like this, select sqrt64 from M, you know that this sqrt64, there is no column like this in M table. So here it becomes a pseudo column. Okay, a column which does not actually exist in the table. Okay, so this is a pseudo column. So we, as we saw in our presentation here, that this dual table can be used to return a pseudo column also, a constant also, a pseudo column also, or an expression also, right? So that is why we use it. So that is why we use the dual table. But I've shown you we can use this M table or any other table with user data also. But when we are checking certain things which are not part of any table, then the dual table would be the best thing to work with, right? So if you describe dual once again, dummy is the column name and value is the X. That is only one thing there. And if you display this, it would show like D comma X. But if you use something like this, it will show you the contents, right? Okay, let's now work with this arithmetic functions. Let's first have a look at it. I've listed the functions for you. The absolute value function is there, ceil function is there, floor function is there, mod function is there, power function, sine, sqrt, trunc, round, exp. So most of you've already seen this thing. Like we talk of ABS function, then there is a function ABS, then FABS, LABS. All these function variants are there in the C++. If you work with it, I'm sure you've worked with the ABS function in C++. So if you're dealing with floating numbers, then the function is FABS in C++, like this. Ceil, floor, all these functions are available in C++ also, right? Okay. So how to use these functions, right? Let's now discuss that, how we can use these functions. So we have the absolute value function, the ceil function, floor function, mod, power, signs. All of these functions do some functionality. Let's work with these functions in our SQL, right? So I'll be working with each category for you. Okay. Kindly keep on noting, and if there are any doubts, you can ask in the doubt session. So I can use, say, select absolute. Okay. So you'll get a positive value, right? You understand that the absolute value returns a positive value. If it is positive already, then it does nothing, right? Okay. Then similarly, we can use the ceil. Okay. Let's use the ceil and floor for you in one function itself. So obviously, if I use it, ceil 3.4 and floor 3.4, you see the answers here. Ceiling returns a higher value, floor returns a lower value. Both of them return the integer values, right? So what's next is the mod and the power function. So let's work with the mod and the power functions. Mod is your percentage or the modulus operator. So if you use here, say, you can use this, and power also we can use. Okay, I'm using these two functions, mod and power. So the answer would be 5. You see 55 divided by 10. So the remainder is 5. So mod functions returns a remainder, right? And the power function returns the first argument raised to the power of second argument. So 5 raised to power 2 is 25. Let's just vary it a bit here. Okay. Let me make it minus 55. So you see it takes the sign of the first operand. And if I just make this as negative, so in just like your C++ percentage operator, the mod function takes the sign of the first argument, right? And if the first argument is lower than the second argument, then the first argument is the answer that you already. Mod 5,10 would always return 5. You don't need to calculate it, right? Then next is our sign and SQRT. So let's see how the sign function works. Select sign, say minus 23 from dual. One output you see, minus 1, right? If the argument is negative, the answer is minus 1. Second category, if the argument is positive, the answer is plus 1. If the argument is 0, the answer is 0. So 3 cases are there, minus 1, plus 1 and 0, depending on whether the argument that you are providing to the sign function is a negative number, a positive number, or 0, right? And SQRT we have already seen. I'll just run it once again, say SQRT, and I can write here 68. So you can see this value of the square root of 68, right? Then next is the trunc and the round functions. So these are interesting. Okay, let me just clear the screen. The trunc function and the round function. So round and trunc are both doing rounding off, but in a different way. Let's see how. Let me first run the round function for you. So say I can write something like this, and then I can write like this. Okay. So select round this. That means I want to round off this number to 2 places of decimal, right? So 2 places after the decimal is 7, 8. But because we have a 9 here, okay, the next digit, if it is 5 or more, it would increase this 8 to 9. So all of you know that the answer would be 56.79. That is what rounding off is. And if I use an argument like this here, you'll see the change. It would be 56.78. That thing you already know. If instead of round, I use trunc here. Okay. If I use trunc here, then obviously it means that just keep the two places of decimal and truncate the rest. No rounding off. So 16 would be truncated. So the answer would be 56.78. And if you use even a digit more than this 5 here, even then the answer would be 56.78. That is the difference between rounding off and truncation. So look at this, okay, and look at this. Okay, see the difference in answer. Okay, truncation means simply whatever is required we keep it, whatever is not we truncate it. So here 56.7876 up to two places of decimal. So we keep two places, 7, 8, we truncate the rest. So this is one way that you can use round and truncate. Let's take another example and pay attention now. Let's see what you can tell me about this. Let's take a small number. Okay. Now, if we use this like trunc 112 comma -2 from dual, okay, what will this do? So now if I use the trunc in this way, okay, all of you have a look at it. If I use trunc like this means truncate this number to the nearest 100. -2 would mean to the nearest 100. So the nearest 100 to 112 is 100. Okay. But even if I use this as 192, now the nearest 100 to 192 is 200 and not 100. But in trunc, it always picks up the lower value. So again, the answer is 100. But if you go with these, like with the round function, okay, so just make a guess. Yes, the answer would be 100 because 112 is nearer to 100, right? And if I use a 192 here, the answer would be 200 because this statement says find the value rounded off to the nearest 100. So the nearest 100 to 192 is 200, right? So the answer is 200. Okay. Similarly, if we make a variation here, say to the nearest 10, okay, -1 would mean to the nearest 10. Nearest 10 is 190. Okay, the next 10 is 200. So we have 190 as the answer. But if I take it as 197, the nearest 10 is 200, right? So 200. So if we go with something like this and we go something like this would mean to the nearest 1000. Okay, so we have the nearest 1000 is what? 1000 or 2000? 2000, right? So if I just make it 1297, now the nearest 1000 is 1000. So I hope you understood what the negative argument in trunc and round means. -1 would mean to the nearest 10, -2 would mean to the nearest 100, -3 would mean to the nearest 1000, and so on. And then I think what is the last function that we have there is the exp function. All right. Exp function is simple. E would mean, let's just check it here, exp1 from dual. Okay, so it should be 2.718. Yeah, that is the e raised to power 1, where e is 2.718. Okay, the value of e is 2.718, right? If I use 2, it would be the square of this. Okay, this would be the square of this. That is what exp means, right? So this is how we can work with the arithmetic functions. So let's now move to the next category of functions, that is the character functions. So I've just listed some character functions for you: chr function, concat, init, cap, lower, upper, lpad, rpad, lprim, rprim. Like all these functions are there, which do some character manipulations, right? Some of them are returning numeric values, like this sky function, the length function. They return the numeric values. The rest, they all return character values. Okay. So let's have a look at their functioning here in the SQL command line. So let's work with the chr function first. Okay. So chr would mean, we see the character is D. So the sky character representing 100 is D. Okay. Similarly, if I use a 65 here, it will give you a capital A, and so on, right? And if you look at these functions, it's the variant here would be the ASCII function. Okay, if I use an ASCII here, okay, and if I use a capital A here, it would return 65. So these are the analogous function, like CHR and ASCII. You provide a number here and you provide a character here. Okay, like this it works. ASCII of A, ASCII value is 65. Similarly, if you look for the ASCII value of say lowercase a, it would give you as 97. Okay. Then concat function is simple. If you need to concatenate two strings, so select concat. Say first string is Ajay and the second string is Sharma, right? So if you just concat it, it would do it without any spaces, of course. Okay, and the heading would take the size of whatever the output is. Okay, so maybe we can use some heading here. Let's see what it comes, whether the heading comes fully or not. No, it will come to those many characters only, right? This is concat. Init cap. Okay, init cap would make the initial letter, the first letter, as capital. Init cap will take one argument. Okay, the first character of the string becomes capitalized. Okay, then lower upper you already know. Okay, so if I use a upper function here, it would just make it in all uppercase, and if I use a lower function here, okay, it will make it in lowercase. That you understand. Then let's see LPAD and RPAD. Okay, these would be something which you don't know as yet, I suppose. So select say LPAD, and I can pick up some name here, say some string, comma, say 20. Let's see what it does. Okay, so once again, like we see, you know, when we want to represent a string in certain width, I'm saying represent this string Ajay Sharma in a total width of 20. Okay, and the rest are padded as blanks. So you can see the blanks here before Ajay Sharma, right? Okay, so you can take another character to do the padding. Okay, so you can just use this character star here. Now whatever space is left would be padded with leading blanks. Left padding, leading, you know. So the padding would be from the left. You can see the output here. Okay, L pad would means left or leading, and right pad would means right, R pad, and would be trailing. Okay, all right, let's use R pad now. Okay, so it would be the other way around. So L pad would mean a right justified output with leading spaces, and R pad would be a left justified output with trailing spaces, right? So if we can use some character, even that is fine. Okay, I can use any character here. There's no restriction on that. Okay, the padding character I've used star and dollar. You can use it. That can be the optional third argument. Otherwise, it runs with two arguments also. When you use two arguments, then the padding is done with blank spaces, right? So LPAD and RPAD, I think clear to you. And then LTrim and RTrim. Let's work with this. Let's work with this LTrim, right? So if I take this character here and I take this here, then obviously nothing will happen to my string. I'll get the output as Ajay Shah, right? It's because what I'm trying to do here is I want to trim the occurrence of the first character. If this capital A would have been the first character here, then it would have been trimmed. So let me run it again for you. Let me just make it a lowercase a. So now that character is trimmed. Okay. And if I take it as J, then obviously nothing happens because J needs to be the first character from the left if it needs to be trimmed. Same is with the R trim, that is trimming from right. Okay. And if I make it A here, then obviously you can see the output. I think it's clear. This A is the first character from the right. Okay. So it is trimmed here. Okay. And if I write something like S here, okay, then nothing happens. So this is how LTrim and RTrim work. Then length, obviously, you know, length function is simple, returns the length of the strings, including the blank spaces. So if I use length, this name Ajay Sharma, it returns 11, right? One blank is also counted. Okay. Then last one is substring. So let's work with substring. If I want to, extract a string from a small string from an existing string, I can just give the starting and the number of characters. So I'm saying start from the second character and extract 4 characters. See the output. Okay. This is the, see now what, why this output JAY is there. Second character is this J. Okay. So in SQL, while you're working with strings, it doesn't start with 0. The first character is numbered index as 1, the next as 2. So I'm saying starting from second character and taking up 4 characters. So this is the length, total 4. So JAY space. That's why it's showing here, right? So if I use it again here, just to be more clear, let's pick like 6. Okay. So now I'm saying starting from second and picking up 6 characters. What it would be? 2, 3, 4, 5, 6. So the output will include a SH now. Okay. 6 characters total, right? 2, 3, 4, 5, 6, 7 index, but 6 characters, right? So starting from 2, 6 characters. So these are the 6 characters starting from 2. A space is also included here. This is what substring is, right? So that's the end of today's session. Just a recap, we have covered the data models in today's session about the relational, hierarchical, and network models, and like which model is best to represent data, and which model is free from the anomalies of insert, delete, and update. And we finalized that relational model is very much suitable to represent data, right? Then we discussed about the functions in SQL, and we discussed about the dual table, which is owned by the user sys, which can be used to just check for pseudo columns, expressions, and constants without having a table having user data, right? And then we discussed about the arithmetic functions and the character functions, right? So the arithmetic functions, the list is there in front. The character functions we discussed. And in my next session, next week, I'll be discussing the other categories of functions. Then I'll be discussing a very important concept of joins. And in the theoretical portion, we'll be discussing about the entity relationship model or the ER model. So till that time, just keep watching videos on my channel. And I'm closing this session here now. Thank you very much.